Good morning, friends. Myself, Mukesh Kumar Khandelwal, Deputy Director Research and Development in Jawaharlal Nehru University. Here I am in School of Engineering. So today we are going to discuss about the electromagnetic wave, electromagnetic radiations, what may be its benefits, what are the several hazards with the electromagnetic wave, what precautions we should take for the prevention. So let's start. So I have made this lecture in three sections. In first section, we will discuss something about the electromagnetic wave, and I have prepared this lecture. I'm assuming peoples are here from the different sections, and so to address all the participant and to all the listeners, I have made this lecture in some interesting way. Several type of pictures, several type of videos is being used in this lecture, so I hope you will enjoy this lecture. Several basic things will be discussed in the first section. Then in the second section we will discuss about the benefits of the EM wave, electromagnetic wave, what are the different applications, why we need this electromagnetic waves, and how we are using it in the present scenario. And in the last section we will discuss what are the different hazards, what the precautions we should take for preventing us from these harmful hazards. So okay, let's start. So this is the several topics. First section we will start with the audio waves, different type of signals we will discuss. So uh, and in the later section of this part, we will also discuss what is the generation mechanism of the electromagnetic wave, what will be the wavelength of the electromagnetic waves, and what are the different sections, how we differentiate different type of electromagnetic waves. So let's start. So let's start with the audio waves, and please be free, and please try to enjoy this lecture. And this is very basic things. Since your childhood you are observing, you are doing several experiments. So audio wave is just a wave which travels on the particles. Means we can say that audio waves needs the particles to travel. Means if there is no medium, there is vacuum, then audio can't travel. So in air particles, on the air particles, audio can travel. So you can hear from here some sound is generated, and it is being transmitted in the air. So the signal is being transmitted from this point to this point, you can see here. Then I have put several pictures in this figure. You can see here someone is clapping, and the particles are vibrating. So there is a mechanism of vibration. Particles are vibrating and it is going in the air. You can see the progress of the particles here. These are moving. So such type of signals, such type of, now look at the second figure, such type of signals is being transmitted, it is being recorded, and we can say this is audio waves. Audio signals are being transmitted. You can also observe when playing some songs with some type of media player, such type of signals is being observed there. So these are also type of audio waves. Second, in this figure you can observe such type of vibration is being shown. Means, and these vibrations are related with the sinusoidal wave signal. So you can estimate, we can estimate any type of waves, not only any type of wave. Means several type of waves we can estimate it, we can analyze it with the help of sinusoidal wave, because most of the waves are having an envelope of like sinusoidal waves. So you can see how audio waves is progressing. So now we will see what are the energy strength, what energy these waves are having. So let's start with some GIF files. So you can see here in this experiment. So please try to sense what is the strength of signals. Here some audio waves is applied to this water, and you can see how it is being disturbed. You can observe what is the strength of this audio waves, and what is the strength of the signals. We will gradually move towards the electromagnetic wave, and we are starting from the audio waves. So This is the power of strength of audio waves. So let's move to the next experiment. So now you can see someone or one researcher is trying to place the water droplets within the audio signal. So you can see it is look like a magic. So it is happened due to the audio waves. So this experiment is done by someone and available on Google. So you can see the strength of audio waves also in this figure. So next experiment, you can see it is programmed by someone, and the strength of audio waves is programmed in such a way then some type of this art is being captured, and they are making some type of these designs with the dust particles, or you can say some other type of particles, and these are feeling the vibrations, so you can sense the strength of the audio signals. So these slides I have placed you to show you the strength of the audio signals. So now you can see the effect of vibrations, because audio signals are also related to the vibrations, and you can see how both the peoples are making the design. So it is also happen. It is also happening with the vibrational power. Some type of audio signals is also involved in these structures. So I hope you enjoyed these videos. So let's move further with our lecture. So you can see in this experiment, uh, oscilloscope is connected with some type of receiver, and someone is clapping, and the strength amplitude of the signal is being increased. When he claps, the strength of the signal is being increased. So that is the strength. We can capture it. So you can see another thing, audio signal is being converted into the form of electrical signal, and you are observing it through the oscilloscope. So now let's move towards the electrical signal. So electrical signal is generally a voltage or a current which conveys some information. Okay, so we can divide it, we can classify this current in two categories. One is the direct current, second one is the alternating current. So you can see in this figure, this is the direct current. Amplitude is almost stable with that time. Okay, and this may be a random graph of any type of signal. We can say the analog signal maybe. Okay, and the AC alternating current, the alternating current is in the form of sine wave. So you can see this sine wave, and I'm just covering the very basic things, and all of you are aware about this. But maybe I'm trying to recall you all the things. However, you know all the things. So this is sine wave, and we are saying a two pi phase difference is there. Here phase difference is pi. Here phase difference will be pi by 2, and this is the amplitude and this is the phase. It is varying with time, that is the 2t. So what is the wavelength? So we can say the wavelength, this is the wavelength of this signal. Okay, so and in this figure you can see the sine wave is related to a circle, means it is moving in a circular motion, means we can relate a sine wave with a circular motion. All the angles now 0 degree, 30 degree, 90 degree, 120, 180, 270 degree, and 360 degree is related to the phase difference of the sine wave. So means we can say if a particle is moving on a circular motion, or if a particle is moving in the shape of sine wave with the envelope of the sine wave, we can correlate both the cases. Okay, so the electrical signals move in the form of sine wave. So let's move further with the basics. So two type of signals are there. One is the DC and second one is the AC. So for the DC, we have shown here a battery is connected. Battery is producing a DC type of signal, and you can see what is the graph. And the AC signal, it is the alternating current. And you can see, you can observe the alternating current. Okay, in this GIF file, you can see here here a battery is connected, so positive and negative sign are fixed, and the motion of the current is like this. It is in the same direction. But in the case of AC, you can observe here positive and negative sign are changing alternatively, and the direction of current is exchanged when the second cycle is come. So it is exchanged. Okay, here you can also observe DC is a constant current and AC is in the form of sine wave, and it is a representation of this figure. You can see, you can estimate it, what is the DC and what is the AC. So all of you are aware about this. I'm just recalling your memories of school time. So that is the thing only. So let's move further with the DC and AC concept. So all of us are known, this is the direction of current, and the direction of electrons is reversed to the direction of current. So this is the case of DC, and for the case of AC, you can see the direction is reverse after a cycle. So you can see for a cycle electrons are moving in a direction, and then and for the another half cycle the direction is reversed, and this type of such type of alternating current is being observed and being captured. So that was something about the electrical current. So let's move towards the magnetic field. So magnetic field can be sensed with this type of magnet, permanent magnet we are also having, and these are the circular lines, these are the closed loops, and we can estimate it through the magnetic probe. Like I'm not going in the detail because I have already mentioned I am covering this section, and I am assuming peoples are here from the different backgrounds, so I'm not going in the details. So you can see here these are the magnetic field, and through the magnetic probe we can sense it in our terms of sine wave, and we can sense the phase. Okay, so it is also related to the form of sine wave, so I have already mentioned. So that is the sense of magnetic field, and these are some basic again the schooling concept. So study two type of fields may be there, the steady and the time varying. So if this conductor is having a DC current, so steady magnetic field is being generated. We can estimate the direction of magnetic field from this figure, and you can see here what is the orientation of field. Initially there is no current, so these arrows were straight, and when there is a current, then the magnetic field is being generated. So that is that this GIF want to tell you, and this is again the rotation of magnetic field is being shown. So that is some type of steady magnetic field. Now the sinusoidal case is there. You can observe the direction of current and the direction of magnetic field through the sinusoidal case. Here you can see what is the orientation, what is the direction of the magnetic field, and what is the direction of the current. So we can say whenever a charge is moving within a wire, it may produce a magnetic field also. So here we can see both electric field and magnetic field are related to each other. Means electric current is going inside the wire, and it is responsible for the generation of the magnetic field. So both are related to each other. So here you can see the generation concept of AC here. So here a galvanometer is connected, and in this figure you can see the voltmeter, the needle of voltmeter is going in one direction and then again in one direction depending upon the orientation of this magnet. So this is a complete circuit. Complete circuit means it is well connected circuit, and this voltmeter is connected with a load, and we are just passing this magnet for this. So this was the Faraday experiment, and you can observe the motion, the movement of this needle. Okay, so this is the concept of generation of AC also through the magnetic fields. So here all of us are well known to this concept. So here in this magnetic field a coil is moving, and AC current is being generated. You can observe here AC current is being generated through this coil, and we can connect a load resistance. So this is the motor concept we can see here, and the direction can be observed here. When it is in the 0 degree position, means that is considered as the 0 degree. So you can see what is the phase, and 90 degree condition, what is the direction and how the current is moving, and it is now 180 degree direction. So at 180 degree, what will be the amount and what will be the phase of the generated current over there. So it can be estimated through this graph. So we can say AC current, a sinusoidal wave is generated through this experiment. Rotor is moving within the magnetic field. So from this point till this point, we can say, and as per the Faraday law, a time varying electric field can produce a time varying magnetic field, and a time varying magnetic field can produce a time varying electric field. So that is the concept of electromagnetic field. So combinedly we call it electromagnetic field, because there is the electric field also and there is a magnetic field also. So let's see, now we will realize what is the electromagnetic field in real sense. So you can see here initially. So first of all, I would like to attract your concentration towards this figure. So first of all, suppose there is a charge, there is a stable charge. You can also see this GIF file also. Initially there was a charge, it was stable, and it starts to move. So what happened? There is a difference between old fields. So you can see here these are the old field lines, and when the charge starts to move, a new field lines is being generated, and there is a kink, there is a difference, there is a kink between both the fields, between new field and the old field. So we can estimate, so this kink is really responsible, you can say this kink is really responsible for the generation of electromagnetic field, and this kink moves in the space, moves in the medium, and this is the reason for the generation of the electromagnetic field. So let's see in detail. So in this video you can see what is the, so this was the stable charge and it accelerated. So you can see these are the stable field lines. So when it accelerates, so there is a kink between the old field and the new field, and this kink starts to propagate in the medium. So that is the main reason for generation of the electromagnetic field. And this kink moves like this. You can observe how the kink is moving, how the electromagnetic field is being generated through a single charge. So the condition is, first of all, the charge was stable and it starts to move, or the charge starts to accelerate or de-accelerate. So acceleration or de-acceleration of electric charge. Electric charge means, in the previous figures we have shown you the um, electric current is moving on a wire and it is producing the magnetic field. So the electromagnetic field is being created through this kink. So you can estimate it. Now the dipole means, in previous figure you observe the single charge. Now we are having the two charge, means positive charge is there and negative charge is there, and these are accelerating like this. And how the field is being created, so it is shown here. So these figure will tell you what is the generation of the figure. So in this figure I may mention, so the charge is being supplied by this, and we can call it a dipole antenna. And you can see this pink field is the input field, input signal which is fed to this antenna or dipole antenna. So let's see this figure. So you can say two charges are oscillating, positive and negative charge, and in such a way the field is being generated, because we have observed single charge is also moving and it is creating the field. So you can see in this figure, again I am playing this video, so just a minute. So you will see Now it is being played. So two charges are moving, it is accelerating. So if you will see the velocity when the charge reach at their end, the velocities become zero, and then when they cross each other, the velocity is maximum. So we can say the acceleration and de-acceleration is there, and due to this acceleration and de-acceleration, a kink is being generated. So you can see this should be the field lines when they are at the end position, and this line should be the ideal line. But the due to the acceleration and de-acceleration in the velocity, this is the realized field, and this would be the expected field. Ideally this field line should be there, but due to this acceleration and de-acceleration in the velocity, the realized field line is there. So there is a difference. So this difference is creating this kink, and these waves are generated in the free space. So you can realize it how two poles, means the dipole is oscillating and generating the electromagnetic field in the free space. This is the concept of the dipole antenna. So you can see in the dipole antenna, we have given a input signal, and this part is the transmission line part, means a wire, and this part is the antenna part. So we can see here a charge is one time positive cycle is there, one time is negative cycle is there, means positive and negative is oscillating from one point to another point, and this type of EM field is being generated. In this figure, these blue lines are the electric field lines, but there will be also a magnetic field lines orthogonal to these lines. Okay, so in this figure only electric field lines are being shown, and this kink is being generated due to the acceleration and de-acceleration of charge, means both charge are accelerating and de-accelerating, and the electromagnetic field is being generated through this dipole antenna. So this is the basic reason behind the generation of the any electromagnetic field, and it moves in the free space. So you can see here, you can observe here how the field is moving. It is being generated. Suppose here a dipole antenna is being placed, and the field is being propagated in the medium. Electromagnetic field is being propagated in the medium. So you can see here the pink line is showing the input field. You can observe here sometime here is positive and negative is occurring because we are feeding this antenna with the AC signal. When positive cycle is coming, this part is become positive, and then for the negative half cycle, this part is become the negative. And due to this blue line, blue part is being generated, means this field is being generated in both the direction. And one more thing is there, the direction is the length of the antenna is lambda by 2, means for the maximum radiation, for getting the maximum radiation, the lambda by 2 distance should be there. Because if we will draw a sine wave like this, so we can draw it like this. So that is the lambda by 4 part. Lambda by 4 maximum is occurring at the lambda by 4. Okay, so when maximum occurs, there should be some discontinuity. So we can observe this graph like I have drawn this from this point to this point. So this distance is lambda by 2. So the total length of the antenna should be lambda by 2 for getting the maximum radiation. And lambda is related, lambda is equal to C by F. So at which frequency your antenna will resonate? So it depends on your length of your antenna. This is the simple concept of the dipole antenna. This is the main frequency which is to be generated. So if this is 2.4 gigahertz, so we can calculate what would be the length of your antenna for radiating the 2.4 gigahertz, and c is the speed of light here in the free space. So like this, the field is being propagated in the free space through an antenna. So these are the field lines we have already discussed. For this figure, here we can see the both charges, means positive and negative. You can see the location, and maximum velocity is occurred here, and both charges are crossing each other. And in this figure here the positive charge, we are talking about the input field, applied input field. So applied input signal, so positive is here and negative is here, and mm, so we can say now the charge is changing their position, and after that cycle positive is here and negative is here. Earlier what was the position? So that was the radiation from the dipole antenna. So we have observed how the antenna radiates, but that is the real scenario. That is the real scenario, how the wave propagate in the medium. So you can see here, these figures, these lines means green line and blue lines are the electric field lines, and these red lines are the magnetic field lines. At each point, electric field and magnetic field are orthogonal to the each other, and they will be orthogonal to the direction of propagation. So suppose if this is the E field and if this is the H field, so that would be the direction of propagation. So we can estimate all three things will be orthogonal to each other. So that is the real scenario. In this figure, in the second figure, you can observe the blue lines are showing you the electric field lines, and these red lines are representing the magnetic field line. So in this way, the field is moving, and the final radiation, how the field looks, even we can't see the fields, how we can realize the fields? So a dipole antenna, the pattern, we call it the pattern, radiation pattern of this antenna looks like this. This is the radiation pattern of the dipole antenna. So it is looking like this. So let's see in detail. So in first figure, please concentrate on the first figure only. So this is the radiation pattern of a dipole antenna. So you can see from the all direction, we call it the omnidirectional pattern. So how we do its study? So in the second figure, now please concentrate on the second figure. So we do the study in few major planes, few orthogonal planes. So there are three major planes. Suppose we are taking it x, y, z axis. So one will be the xy plane, second will be the xz plane, and third one is the yz plane. So we can take the impression of this radiation pattern on the particular plane. So we can see here, it is the observation on this vertical plane. So electric field is being shown here, and in this figure, horizontal plane, we can observe the magnetic field. So here it is the pattern. So we call it the pattern. We do the study of any antenna in two major planes, that is the orthogonal plane to each other, E plane and H plane. So we can call it E plane and we can call it H plane. Okay, so that is the real scenario, and we sense, if we sense and if we realize the field, that is the scene. It looked like this, it looked like this, means we can say here the strength of the field is more in comparison to the field presented here. Here is the minimum field and here is the maximum density of signal. Okay, but I have told you, we do the study of this field's radiation pattern in two major planes, so we can call it two orthogonal planes. So here we are showing you the electromagnetic field, or we can say the planar electromagnetic field. Even it is radiating, it is being radiated like this. So this figure is showing you the outer dashed lines, showing you the real pattern, but we are studying this field in the two major planes. So we can say this is the electric field, blue part is the electric field, and corresponding magnetic field is shown here in the yellow part, and this is the direction of propagation. So in this way, the electromagnetic field is moving in the medium, in the free space, and in or any medium. Okay, so at any point, if you will observe the electric field, the magnetic field, and the direction of propagation will be orthogonal to each other. So that is the concept of electromagnetic field, which is moving in any medium. So that is about the electromagnetic field. So you can see here in the green lines, through green lines, E field is represented, and through the blue lines, the magnetic field is being represented. The orientation of poles, orientation of direction is being observed, it being analyzed. It is depending upon the direction of electric field, whether it is in upward or whether it is downward. So the direction of motion of magnetic field is also changing according to it, so we can observe it. So now let's talk about the wavelength, so because we need it. So if someone is not able to recall this concept of this school concept, so we can uh, help them. So this is the mainly wavelength when we are studying a sine wave. So this is the amplitude of that wave, and this is the wavelength, and that is the frequency also. One part is also a frequency. If we are starting this signal from here, so one cycle is completed. How many cycles is completed within 1 second? That is the frequency, and it is related to the wavelength also. So wavelength and frequency are the two major parts, and lambda is equal to c by f. So both things are related to each other. Wavelength would be in terms of distance, and frequency would be terms in number of cycles per second. The unit of this f is hertz, and we unit of this, so maybe meter, millimeter, centimeter, because it is representing the distance parameter, and c will be the speed of light. Okay, so that is the wavelength. So now we can discuss what is the frequency. So we can see here, this is the lower frequency band, and this is the higher frequency signal. So we can say, suppose this is the 1 second. Suppose this is the 1 second. This is 0.5 second. So we can see here the number of cycles completed within 1 second is one. Number of cycle is completed. Uh, one cycle is completed here, and call it 1 second. So the frequency may be the 1 hertz. Now we can see what would be the number of cycles completed for this signal. Maybe 1, 2, 3, 4, something 4 or 4.5, something is there, because figure is not clear. So we can call it, this is the high frequency signal, this one is the high frequency signal, and this one is the low frequency signal. Okay, so we can see this also. If wavelength is high, the frequency will be low and the energy will be low. And the higher frequency signals is carrying the high energy. Means this is the thumb rule. If the frequency is high, that there is a probability of high energy, carrying the high energy. Electromagnetic energy is also carrying the energy. I started this lecture with showing you the strength of mm, the waves. So it is also electric and magnetic field combinedly carrying the field, carrying some strength within itself. So this is some part. So this is the spectrum, and we will also discuss this spectrum in detail in the second part of this lecture. So we can classify this electromagnetic spectrum in several parts, like that may be radio waves, then the microwaves, and that infrared, ultraviolet, and x-rays, and gamma rays. Okay, so this is the classification of the EM spectrum, and the corresponding wavelength and frequency is mentioned here. The frequency is increasing in this direction, and the danger, the main dangerous waves, the hazards, which is more hazardous, is in this direction also. So you can say this is less hazardous, and you can say the gamma rays is the most hazardous to the living things. So this is like this, because frequency is very very high for these waves. So we will also call it so, but in nowadays, so these waves are also described with the ionized or non-ionized field also. We will also discuss in the second part of this signal, and we will majorly concentrate on the microwave frequency band. So we will meet for the next session, and we will start with the next lecture. Okay, next slide.